Good morning. Last class we have discussed about Wagner-Merwin rearrangement. In Wagner-Merwin rearrangement, there was a migration of alkyl group or a shift of a bond from carbon to carbon. That means Wagner-Merwin reaction was coming under or is coming under carbon to carbon migration of alkyl groups. Now another example for carbon to carbon migration is second example coming under this class, that means carbon to carbon migration of hydrogen or alkyl groups or aryl group is second example is Demjanov rearrangement. Demjanov rearrangement. Reactions. Demjanov rearrangement reactions. Actually, Demjanov rearrangement reaction involve Demjanov ring contraction and Demjanov ring expansion. Demjanov rearrangement is a combination. It's a combination of ring contraction and ring expansion. So let us discuss this Demjanov rearrangement with an example, or generally I can define Demjanov rearrangement as, look at here. First, Demjanov ring contraction. Look at here. When a positive charge is created on an alicyclic carbon. Cyclic carbon, rearrangement will occur and will form a new ring with one carbon less than in the original. So Demjanov ring contraction, when it is happening, when a positive charge is created on an alicyclic carbon. So example, you look at here. Here is a positive charge. Okay. Rearrangement will occur and will form a new ring with one carbon less than in the original. That means this is our starting compound. What is the name of this compound? Cyclobutyl cation. So when a positive charge is created, that means this is cyclobutyl cation. Then there is a rearrangement. And will form, you look at here, you get this product CH2 plus. That means you are getting a ring with one carbon less than in the starting structure. Here you can see this is a 4-membered ring, and here it is changing to a 3-membered ring. Okay, and actually this reaction, this type of Demjanov rearrangement is it can revert back. That means this can change into this can ring contraction will occur, or you can say when you come back, this is ring expansion. So this together, this is what is called Demjanov ring or Demjanov rearrangement. Or okay, you can look at once again. When you go forward reaction, you can see that there is a ring contraction. 4-membered ring is contracted to 3-membered ring, and look at here. When it come back, you can see that ring expansion. And what is the name of this cation? This is cyclopropyl methyl, or this is cyclopropyl carbonyl cation. Another name is carbonyl cation. Okay. So this is an example for Demjanov rearrangement. Now we will go to the mechanism of Demjanov rearrangement. Clear? Okay. A classic example we are taking for which involving Demjanov rearrangement. Look at the particular reaction. NH2, here it is NH2. The name of the compound is cyclobutyl amine. Cyclobutyl amine. When it reacts with nitrous acid, or here it is nitrous acid, or that it is HNO2, or you can write it as NaNO2, as you know well, NaNO2 and HCl, correct? So nitrous acid, that is HNO2, or you can write a freshly prepared nitrous acid is prepared by NaNO2 plus HCl, and you get this is unrearranged product, because NH2 is replaced by OH. There is no rearrangement. That means this is unrearranged product, plus you are getting here like this one compound OH. This is a rearranged product. Okay, the same reaction you can start from here also. Look at it here. Look at it very carefully. See, if this is the starting compound, what is I am taking? NH2. Again, if you go this way, this is what is the name of this compound? Cyclopropyl methyl amine. When cyclopropyl methyl amine again react with the nitrous acid HNO2, you get what is that? Then it will become, this one will become unrearranged product and ring expanded rearranged product. This is an example for Demjanov reaction. Now we will go to the mechanism of the reaction. Once again, you look at the reaction. This is cyclobutyl amine. When it is reacted with nitrous acid, you are getting unrearranged product. That means here it is OH. There is no change in the shape of the ring. That means the number of carbon atom is same. Plus you are getting, you can see that there is a ring contraction is occurring, and you are getting, what is that, a rearranged product. Similarly, cyclopropyl methyl amine, when subjected to HNO2, it will undergo ring expansion. When this is subjected, it is undergoing ring contraction, and when this one is subject to cyclopropyl methyl amine is subjected to a reaction with HNO2, it will undergo ring expansion. That means this is coming to, that means this is the rearranged product. Okay. Now look at the mechanism. First, this nitrous acid is having a very important role in Demjanov rearrangement. nitrous acid, that means I can write it as HNO2 can be written as OHNO. Okay, OHNO in presence of acid, H plus. This acid can be, you look at here, HNO2 can dissociate into H plus and NO2 minus. This H plus, that means the ion from dissociated HNO2 will react with the undissociated HNO2. This that means this H plus can come from same HNO2, or you can say that some other acid. If you are taking NaNO2 and HCl, there is a HCl is also present in the mixture. Therefore, H plus. Anyway, it can come from HNO2 or some other acid H plus. This OH minus, the lone pair will attack on this H plus. Okay, and you are getting OH2 NO. The actual structure of this NO is N double bond O. N double bond O. Okay, then since this lone pair is attacking the OH2, this oxygen is getting a positive charge, and you can see that. Let me erase this one. Okay. That means OH2C lone pair is attacking on H plus, so it is getting a positive charge. Then N double bond O. Now what is that? You can see that minus H2O, and you get NO, and you are getting NO. What is the charge of nitrogen? Here you can see that since the bond is breaking from nitrogen, here is this positive charge. That means this is nitrosonium ion. This is acting as the electrophile. Okay, nitrosonium ion. This is the first step happening in the Demjanov rearrangement. You can look at it here. Nitrous acid is reacting with acid. That means H plus, it can come from nitrous acid or some other acid, like when you are taking, if you are preparing nitrous acid by NaNO2 and HCl, H plus can come from that acid also. Anyway, your OH group will be protonated and the water molecule will be eliminated, and you are getting nitrosonium ion. Okay, now in the second step, look at here. Okay, NH2. Okay, NH2, and we have our nitrosonium ion. Okay, and you can see that this lone pair electron is attacking on this positive charge, correct? And you get, see, listen very carefully once again, this is our nitrosonium ion NO, and the lone pair electron on the NH2 nitrogen atom is attacking on this nitrogen, and so you are getting NH with a positive charge, correct? NH2, I am writing it as NH2 can be written as NHH. Since this lone pair is attacking, you are getting a positive charge and it is joined with N double bond O, correct? Lone pair is attacking on this nitrogen, that means NH2 with a positive charge. NH2 can be written as NHH. And okay, in the next step you can see that what is that? This bond. Okay, for stability you can see that minus H plus, and you get what you are getting. You are getting structure like this, ring NH N double bond O. Correct? Now in the next stage, I am writing the same thing. This one, the same thing I am writing like this. That means you can look at it here. NH can be written as NH N double bond O. Same thing I am writing like this. Okay. So this H up. Okay, H is like this. Now there is a rearrangement. Look at it here. There is a proton shift. This bond is shifting to here. Okay, that means N double bond N. This is shifting to oxygen, O minus. Then this proton will attach to oxygen, and you get what you are getting. You are getting a compound like this. Here it is N double bond N and OH. Understood? Once again, NH. There is a proton shift. You can see that this bond is shifting to here. That means N double bond N. This bond is, the bond pair electron is, this electron is moving to oxygen. So minus, then H plus is attaching to oxygen. So OH. Now you can see that this reaction, this product, what is that? Again, H plus present in the medium. H plus will attach. You can see that this H plus or you can say that this lone pair electron will again attack another H plus ion, and you get a structure like this: N double bond N OH2, H is this lone pair rejoins, that means OH2, and it is getting a positive charge. Correct? And again, I think you can see OH2, and in the next stage you can see that again I am going like this, minus H2O, minus H2O, minus H2O, okay, and you get okay, N double bond N, or N2 with a positive charge, correct? Minus H2O, so this nitrogen is getting a positive charge, that means N2 is getting a positive charge. What is this one? N2, this is diazonium compound. Diazonium compound. Now in the next step you can see that look at here very carefully, this bond breaks, and what is eliminating? Minus N2, nitrogen gas is evolving out, and you get cyclobutyl cation. This is the way how cyclobutyl cation is forming. When cyclobutyl cation is forming by diazotization of a primary amine, this is a primary amine reaction of a primary amine with nitrous acid and forming a disonium salt. That reaction is known as diazotization. Here you can see that diazotization is happening, and after diazotization, nitrogen molecule is eliminating, and you are getting You are getting cyclobutyl cation. This way, if alicyclic cation is forming, that type of reaction is known as Demjanov rearrangement. Definitely cation can form in some other way also, but if it is going via this way, that means diazotization of a primary amine, that reaction is known as Demjanov rearrangement. So I am repeating once again the mechanism. First, nitrous acid is protonated from H plus is coming from nitrous acid itself or some other acid, and water molecule is eliminating, and you are getting nitrosonium ion. This is acting as an electrophile. Now our primary amine, you look at here, this is the primary amine. This primary amine is attacking on this nitrosonium ion, and see the rearrangement is NH2 plus, or you can write it as NH. This is the positive charge, and therefore what is that? Minus H plus, and you are getting NH, N double bond O. Or you can write it as the same structure can be written as this. NH can be written like this, NH, N double bond O. Now there is a rearrangement. This bond is shifting to here, and simultaneously this double bond is shifting to oxygen atom. That means here is a negative charge. This H plus is attaching to oxygen, and you get this structure. Now in the next step, again H plus present in the our reaction medium. This lone pair is attacking on this H plus, and here it is OH2. Now again water molecule is eliminated. And you get diazonium ion, and you are getting this one. Now in the next step, immediately nitrogen gas will be evolved out or eliminated, N2 will be eliminated, and you are getting alicyclic cation. Here it is cyclobutyl cation. This is the first step, or you can say that this is this way cyclobutyl cation is forming. Now, this cyclobutyl cation react with water. That means this is a aqueous medium, and here you can see that in different step water molecules are eliminated. Anyway, in the reaction medias water molecules are there. When it is reacting with water, there are two possibilities. Okay, we can look at it here. Okay, direct attached to this positively charged carbon, that means OH, this one I can say this is cyclobutyl cation plus H2O. This lone pair is attacking on this positively charged carbon, and you get here it is a ring, and OH2, OH2 positive charge, correct? I think it's a very simple step. This lone pair is attacking OH2 with a positive charge. Now next step, as you know very well, in the next step, minus H plus, and you get, here it is OH. There is no rearrangement because what is that, in the place of NH2, what is coming, OH is coming. Okay, now look at the second possibility. Now, this is important. Here only we are explaining what do you mean by Demjanov ring contraction. Okay, see, look at here. Here is a positive charge. This is a positive charge, and when there is a positive charge is created here, you can see that there is a bond shift. Okay, now you can see that here is a positive charge on this carbon. That type, this bond breaks from this carbon and it is moving to here. That means bond shift. 1, 2, bond shift. Okay, this bond breaks and shifting to this carbon. Now you get a structure like this, and it will become 3-membered. Since this is here is no positive charge, the bond breaks and joining here, and here this end is having a positive charge. Clear? Okay. Or you can write it as this means what is that? Here it is CH2 with a positive charge. CH2 with a positive charge. Look at it here. This bond breaks from this carbon and joining here, and you are getting a 3-membered ring. And this one is, since the bond is breaking from this carbon, here is a positive charge. That means CH2 with a positive charge. And next stage, as we have discussed earlier, H2O. Okay, the lone pair is attacking on this carbon, and what will form? You will get like this: CH2 OH. H with a positive charge, and okay, now what is that? Minus H plus, as discussed earlier, you get what is that? CH2 OH, or you can write it as what is that? OH. So here you can see that ring contraction is occurred. Clear? So earlier we have discussed how the cyclobutyl cation is formed. Cyclobutyl cation can immediately react with the water molecules present in the medium, and one is unrearranged product because the OH2 is attacking directly on the positively charged carbon, and you are getting OH here. Okay, there is second possibility. When a positive charge is created here, what will happen? The ring, this bond breaks from here and it is joined like this and leaving a positive charge here. That means you are getting a positive charge on this. Actually, here it is CH2 positive. On that positively charged carbon, the water molecule will attack, and on that molecule, the OH molecule will come. This is what is the case. This is the case of ring contraction. Okay. Now once again I am writing the first equation which I have written, that is here it is NH2 when react with HNO2, it will change into, here it is OH plus what will form as we now we understood how these two products are obtained. Clear? Now I have explained how these two products are obtained. Now one more equation I have written like this. What is that? When you can see that this is NH2. What is this one? Cyclopropyl methylamine. Amine is treated with nitrous acid. You get these two products. Here you can see that when you go this direction, you can see that first product is unarranged product because NH2 and the same place OH is coming, and the second one is rearranged product. That means in the second product, that means there is what is happening, ring contraction is happening. Here it is 4-membered ring and here it is 3-membered ring. And now I am coming to this one. Okay. Cyclopropyl methylamine. Okay. reacting with nitrous acid, HNO2, nitrous acid. HNO2 means what is that? H plus and NO2 minus. Okay, here reaction is very simple, and this lone pair is directly attacking on this H plus. Okay, HNO2 can be written as H plus and NO2 minus. So NH2 is directly attacking on H plus present in the nitrous acid. Okay, attacking on H plus, and you get a structure like this. Okay, here it is NH2 or NH2H, NH3 with a positive charge. Correct? Because this lone pair is attacking on this hydrogen, that means this will become NH3 leaving a positive charge. In the next stage, you can see that in the next step, you can see that this NH3, this bond breaks from here, and what is eliminating? NH3 gas is eliminating. You can see that minus NH3 gas is eliminating and leaving a positive charge on this carbon. That means you get, here it is a positive charge. Clear? This bond breaks from here. Okay, this bond. Okay, once again I am writing, this bond breaks. Okay, and minus NH3 leaving a positive charge here. That means here it is CH2 with a positive charge. Okay, I am continuing. Okay, now we are having, here it is CH2 with a positive charge. Now you look at here, as we have discussed earlier, with H2O. Here it is H2O. Okay, now in the first case, you can see that this lone pair is directly attacking on this positively charged carbon. Okay, that means you get, here it is a ring, and here it is H2O, and here it is OH2 with a positive charge. OH2 with a positive charge, or you can write it as OH with a positive charge. Okay, and now you can see that minus H plus, what you will get? Okay, this one. That means the H2 is directly attacking on the positively charged carbon, and you are getting this one. That means when you take cyclopropyl methylamine, first you are getting, for this cyclopropyl, this is an unrearranged product. See, unrearranged product. Okay, now next is a possibility. Okay, look at here. Okay, next possibility, I can write the same thing. That means here it is like this. Here it is CH2 with a positive charge. Actually, this again I am writing the same thing. Cyclopropyl, this cyclopropyl carbonyl cation, I am writing the same thing. This cation. Now what is happening? If a positive charge is created on this carbon, okay, alpha to this ring, you can see that this bond, okay, this bond breaks from here and will join with this one. Okay, or I can write clearly like this. Okay, the same thing. Okay, CH2 plus. This is better to understand. Same thing. CH2 here I have written like straight, and the thing here I am writing as up. Okay, CH2 bond is up. Now it is very simple to explain. This bond breaks from this carbon and it will join with this one. So what you will get? You will get okay, correct. And what is that? Since the bond is breaking from here, here is a positive charge. Clear? Now what is that? Or here is a positive charge, and now in the next step, water molecule is attacking. Again, as we have discussed earlier, you get a positive charge. Now you are getting OH here. Okay, that means what is happening here? Once again, this is important in this reaction. Here it is, CH2 is having a positive charge. Then now you can see that this bond is breaking and it is joining with positively charged carbon, leaving a positive charge on this position. That means here it was a 3-membered ring. Now it is changed to 4-membered ring. That means a ring expansion, and you get a rearranged product. This type of rearrangement is known as Demjanov rearrangement. So Demjanov rearrangement is associated with ring contraction and ring expansion. And in Demjanov rearrangement, the cation is produced by in this method. That means a primary amine is reacted with nitrous acid. That way the carbocation is produced. If a carbocation is produced in such a way, the reaction is known as Demjanov rearrangement. Okay, Demjanov rearrangement is important for the conversion of 3-membered ring to 4-membered ring, or vice versa, 4-membered ring to 3-membered ring. Okay, with this we are winding up the mechanism of Demjanov rearrangement, and thank you.